Good morning or good afternoon, everyone. This is Jean-Daniel Rossel, President of the Java Card Forum, and it's my pleasure to welcome you to this second webinar from the Java Card Forum 2022 webinar series. Today's topic is a presentation from Sridharan, Sadakopan, and Murad Faher on digital identity. Sridharan is currently leading the R&D team working on innovative solutions in the fields of digital identity, IoT security, and blockchain security. Sridharan has a master's degree in communication software and network from Nanyang Technology University in Singapore. Murad has been actively participating in various international standard bodies such as the ISO, SC17, and is contributing to standardization initiatives such as the European Citizen Card, Standardization Committee on the ISO Mobile Driving License and Mobile ID, and many more. Murad has a PhD from the University of Toulouse in France. This year is the 25th anniversary of the Java Card Forum, and Java Card is a pervasive technology with shipments over 6 billion units per year for different segments like telecommunication, payment, authentication, access management, and most importantly for today, digital identity. Digital identity is an important segment for Java Card, and this year particularly it's the focus of the upcoming European regulation on the mobile ID wallet. This webinar will show how Java Card can bring security to these identity wallets. We will answer your question at the end of the presentation, so the microphone will be closed during the presentation, but we will open them for the questions. Anyway, during the presentation, if you wish to ask a question, you have a chat box. Just write your question in the chat box and you'll be able to ask it directly, or we will read it during the question period. Note also that this webinar is recorded, so you will receive a link very shortly to the webinar if you want to replay or forward to some of your colleagues. And you will also receive a copy of the presentation for your record, so you can really focus on the presentation and relax and enjoy it. Murad, Sridharan, I think the floor is yours.
Thank you, John Daniel. Thanks for the nice introduction. Hello, my name is Sridharan. I will start the presentation and then Murad will continue some of the sections. Let me start with the first slide. I'm sharing the slide. Are you able to see the slide that shows agenda?
Yes, we do.
Thank you. I hope everyone can see the slide that's showing agenda.
Yes, we do, Sridharan. You can.
Okay, thank you, John Daniel. So we would like to start the session with an overview of what is digital identity and the terminology in general, then followed by some of the recent developments in the standardization space. So let me start with a very broad overview of what is identity. Identity is something that remains same over time. No matter the number of changes that happens, still it points to the same entity or the same person. So with this very high level view, let's look at a bit more specific in detail. Identity is those characteristics that distinguishes one from another. The characteristics can be born with or assigned and occur over time. With this broad definition of identity, let's look at some formal definition as specified in the International Telecommunication Union published document titled Digital Identity Roadmap. It defines identity as a representation of an entity in the form of one or more attributes. For example, in the case of a person, it could be the attributes such as name, height, personal IDs and national IDs, and other biometric characteristics. Then what is digital identity? It's a digital representation of the identity that can be stored electronically and also can be exchanged with a remote entity electronically. So with the definition of identity, let's move on to another terminology that we come across often. It's called authentication. Authentication is a process of proving that an entity is in possession of something that's unique, that's secret, only that entity is in possession and is controlling. There are common form of authentication factors that are based on what someone is or what someone knows or what someone has. So what someone is could be some of those biometric characteristics and behavioral characteristics. What someone knows can be something that the person can remember and present. And the third form of authentication factor, it is what someone has. So these are typically in the form of secure tokens such as smart cards and other security tokens. One of the challenge with this third form of authentication factor, it needs at least the other two form to strongly bind this factor with the owner. So the challenge is how strongly the binding can be established between the owner and the one that the owner is in possession of. So in the later presentation, Murad will explain some of the mechanisms that provide enhanced holder authentication that are being defined in the upcoming specifications. Then with that, let's move on to the next concept, credential. Credential is defined as an object that binds authoritatively via an identifier and zero or more attributes through an authentication factor that's controlled and owned by an entity. So the credential can be used to assert identity of a person or an entity. So the technologies such as Java card and other secure element would help in securing the credentials and will ensure the privacy and the personal data protections are ensured. So in some of the subsequent slides, we will see how the technology can help achieve those things. Then the next slide is to highlight the importance of the user privacy and personal data protection. At the end of World War II, the United Nations Universal Declaration of Human Rights that enshrine the basic, the fundamental rights of any user, such as the privacy. Then building on this Universal Declaration of Human Rights, there has been over the year many regulations and standards and principles have been developed, emphasizing the importance of privacy and security by design. And then until the recent standardization or regulations such as the eIDAS regulation, GDPR, and the most recent one, the eIDAS 2.0, that emphasizes the importance of providing full control to the users on their own personal data. So with that, let's move on to the next slide. It summarizes the evolution of ID document. ID documents are a form of credential that we saw in one of the previous slide. The ID documents have evolved over time, starting from paper-based credential to one with a photo or portrait to bind the document with the user, and then evolving from there with those ID documents with the biometric and other secure element based mechanisms. So some of the recent evolutions involve making use of biometric features to bind the ID document with the rightful owner, and also the mobile form of the factor that stores the ID documents on the mobile. And recent evolutions in the standardization space, such as the ISO MID, that defines how to establish strong binding between the user and the document. And over the last 25 years, JavaCard has been enabling implementation of these standards in secure way that's respecting the privacy and providing personal data protection for the user. So with this quick overview, I will pass the floor to Murad. Murad will highlight the recent evolution in standardization space and how this enhanced user holder authentication that helps achieving the strong binding between the user and the document that the user is controlling, and also the user control and the privacy protection mechanisms. With that, I pass over to Murad.
Hello, everyone. I hope my screen is visible now.
Yes, Murad.
Okay, thank you. So, hello, everyone. Thank you, Jean-Daniel, for this introduction. I would like to lead you through the specific concept of mdoc that you have maybe heard about, that comes from the mobile driving license specification. And we will see how it applies in eIDAS context and what are the benefits of this concept called mdoc. So first, let's set the stage. We do have here the regular, I would say, architecture with a reliant party on the right side, a verifier acting on behalf of this reliant party, and on the left side, we do see this triangulation that connects the data to the user to the device. The issuer in place will, of course, deliver the data and the necessary crypto assets, and we will be focusing in this presentation on the delivery of attribute plus authentication proof to the verifier. As Sridharan already introduced, there are three categories of authentication factors: something you know, something you have, something you are. There might be a fourth category that is somewhere you are, but we'll just consider those three categories that are identified in eIDAS regulation. Moving on, we will consider more particularly two series of standards, one being the 1813 Part 5 and the other 23220 Part 4, that are likely to be referenced in the eIDAS toolbox in the future. This is something that would happen, and we will see how those standards participate to facilitation of the authentication through the interface that interconnects the verifier on the left side to the mdoc. So mdoc at first sight is a representation of the application on top of the mobile microcontroller. It can be, considered as the application embodiment. Of course, it could act as a proxy interconnected with the applet, and underneath, you can see the gray area, the secure element. And here, JavaCard comes into play. Of course, this mdoc is seen from the outside world through the interface that will address it with some specific APIs where the namespace is employed. And we'll get soon into details of this namespace concept. The design from the outset of this standard was based on four pillars. Actually, the application layer rests on four functional principles, being the secure messaging establishment, the API serialization, the data element naming convention, and eventually the transport over mobile communication channels. Those pillars can read from right side to the left side. The left side has follow. with some or over some specific communication channels supported by the mobile, including Bluetooth, Wi-Fi aware, NFC, etc. Data elements that are named according to specific convention are conveyed and serialized through the API interface, and they are secured with a specific secure messaging, taking into account privacy requirements. What matters here is to consider this line, that is this yellow bold line that represents the abstraction layer. And whatever deals with the application side is described by the 23220 series of standards, whereas the kernel of functionality embodying this wallet, so to say wallet, is implemented and specified by the 18013 Part 5, known as the mobile driving license, but actually mobile driving license is but a use case. As you can see in the next slides, the mdoc can represent a personal identification data. It can represent a vehicle registration certificate, or the mobile driving license that I already mentioned, that is but a use case, e-health application, and so on and so forth. The provisioning of this mdoc is something that can happen separately, has static information that is delivered by the issuing entity onto the mobile, and that will benefit from the underlying, you see, functional kernel that will provision that will, I would say, sustain the secure establishment of communication, the communication through the API, the protocols that are supported by the mobile, etc. What we will be focusing on more particularly is the data element, because this data element is something that is hosted by the mdoc, and the mdoc looks as follows. Actually, this concept is fundamental before to move on and to see how it can facilitate the authentication protocol. Here in the gray box, we do have the mobile. Then comes the secure area that you have mentioned that is abstracted by the specification. And the mobile wallet is comprised of a series of mdoc. We just saw how those mdoc can be provisioned separately and with their respective firewall, etc. Those mdocs are built up with several namespaces. The orange boxes here, or yellow boxes, represent namespace. Each namespace itself comprises a series of data elements. Those data elements, each of those data elements is incarnated by a label and a value. A label is the literal naming, or according to some convention, literal naming of the value signification. And those mdoc could, as you can imagine, in the context of eIDAS, host personal identification data, qualified electronic attestation of attribute, electronic attestation of attribute, or any other form of attribute, actually. Just keep in mind, please, that the mdoc is some sort of representation of the application context. Moving on, what are now, step by step, little by little, we'll be considering the authentication using this mdoc interface. First, what are the necessary key material to achieve authentication? At least we need to have on board the device two kinds of keys. One being the device key that will allow to prevention of anti-cloning, to serve for anti-cloning purposes. We do have as well the authentication key or authentication proof key. What is the difference between those two cryptographic assets? The main difference is that the device key will be only triggered upon, you see, user consent. User typing in a PIN code or a password, or in some cases with more, you see, stringent methods like biometric verification or so. But fundamentally, the user consent suffices, you see, to trigger the signature with this device key that will come along with all the outgoing, you see, data delivered to the outside world. This is an anti-cloning key. Whereas the authentication key is triggered not only by user consent, or not at all, I would say, by user consent, but rather upon request from the verifier. The verifier requesting a specific type of authentication will trigger the execution of a signature with this authentication key onto some data binding the session, etc. But the main difference here to keep in mind is that we do need to have two separate keys two separate keys because by essence, the way they are executing operations are different. Hence, those differences can be justified, moreover, by the fact that those keys could be hosted on different tokens. An authentication proof key could be nested into a totally separate token, a hardware token, a FIDO token, or any, for example, electronic identity card, or anything else. And in such case, it will not even be nested onto the mobile. It will be available on a container outside the mobile device. This is as well something that justifies the fact that those two keys should be separate. For common criteria certification, it's obvious that the vulnerability assessment, etc., would require to reach some class of evaluation would require probably those keys to be distinguished and not. But even so, some implementers would tend to use the same key to achieve both goals. I mean, to prevent the cloning and to ensure authentication. But this is not something recommendable, I would say. Now, to put it into practice and to see how this mdoc can intervene and would facilitate the authentication, thanks to this naming convention, what are the requirements? Actually, we do have 4 requirements. First, we need data element concept. And those data elements shall be in dedicated namespaces from within one mdoc. The second condition is to have a set of specific data elements useful to trigger the authentication. As we have seen, a data element is comprised of a label and a value, and this label could be dedicated on purpose to a specific type of authentication. Literally, we could have the H authentication, that is an acronym for holder authentication. We could have H attest, that is an acronym standing for holder authentication with delivery of an attestation. We could have the holder R attest, that is meant for the holder authentication with something you are, and with delivery of an attestation, and so on and so forth. The third condition is that the authentication should rely on either one of the 3 authentication factors or a combination thereof. And the last needed feature is the possibility to deliver an attestation, this attestation being some sort of proof, actually. And here on the right side, you can see that the proof considered as an attestation could bind the key that serves to achieve the signature related to the authentication. And for example, the attestation could embed or endorse the public part of the key for which the private part is involved in the authentication signature. Now, how would this be put in practice? You can see here that with the upward arrows, the verification request or the verified request, this is the request that comes from the reader, let's say, and here the downward arrows in green represent the mdoc response. So if the verifier request, as example, an H auth, it means that it is expected that the mobile perform one holder authentication by default. This by default authentication is up to the issuer and could rely on any of the 3 kind of factor that we have seen. It is up to the issuer to decide as well how the signature would apply and whether this authentication would take place on board the device or with involvement of a remote identity provider. Once this operation is performed successfully, it is expected that the mdoc response convey the resulting the information that would be either yes or no. So this yes/no is a simplistic approach that would spare to the verifier a complex parsing of any resulting information out of this authentication. The yes/no is just something that the verifier would rely on, has it's been executed properly and under the control of the issuer, etc. So this the validation of this yes/no resort essentially to the trust the verifier or to the credence the verifier lent to the issuer. Now, there are other approaches. As example, as you can see here on the other side, the verifier could request the HOT. Once again, that is the keyword triggering the authentication. But this time, he will request as well another data element that is HR attest. This means that the verifier is wishing that to see one authentication performed with something you are, with a factor related to something you are, as example, biometrics also. And this time the response will be once again yes, no, but with additional attestation or proof endorsing the key, the specific key that was involved in the signature of this authentication or in the validation of the authentication process. And so on and so forth. We could have a more complex request that once again start with this HOT that is systematically sent by the verifier to signify that the verification system is expecting holder authentication. And this time, if it comes along with HR attest and HHAV attest, it means that the requester expects two authentication factors to get involved into the process. This means that the verifier doesn't expect only the by default, but rather, you see, specific holder authentication on the ground of those two factors. And this time, the attestation will be returned respectively for each of those factors. Of course, there could be a unique attestation getting both keys that are endorsed by the issuer for those authentication process. This is as well possible. But no, putting it into the context of eIDAS, let's consider that as we do have the facilities of using those namespaces, we could as well launch an authentication request or launch a request that would ask for a specific attestation. We could have eIDAS attest low, eIDAS attest sub, or eIDAS attest high, respectively standing for request for authentication that is equivalent to the level of assurance low. We could have otherwise an request for authentication that would be equivalent to the level of assurance substantial, and so on and so forth. We could have as well an authentication requested to be at equivalent, at the level, at least equivalent to the level of assurance high. And this time, the requester will rely on a specific context, on specific jurisdiction, where the authentication related or the authentication protocol related to those specific naming convention, as example, will provide an authentication or perform an authentication based on two authentication factors. As we know, eIDAS substantial, level of assurance substantial, request at least two authentication factors, and we could consider that the authentication that is demanded when this data element is triggered would be an authentication at least based on two authentication factors, and so on and so forth. This time, the attestation will be returned within a format and checked according to jurisdiction. And you could extrapolate this concept to NIST attestation, visa attestation, global platform attestation, or simply country-specific attestations. Now, putting it into practice, overall, we could have some sort of transaction where, as example, the user would collect one qualified electronic attestation from a qualified trusted service provider in eIDAS context. This qualified electronic attestation is assumed to be signed with a qualified signature by this TSP. And then let's say that later on, the user will request a service or a resource from a reliant party. And the reliant party, in order to grant access to this resource, may need a specific qualified electronic attestation that would deliver some information allowing to the user to reach the requirements that are needed to access these services. The reliant party will authenticate to wallet, which is mandated, and will request, as we said, this qualified electronic attestation. Then the mobile could return with user consent this electronic attestation, and here we could imagine that the reliant party would check the metadata that are, I would say, on the top of this qualified electronic attestation, and this is something that comes directly from the annexes of the regulation. There should be metadata describing the issuer of the attestation, delivering as well identification of the user, etc., and describing possibly the format and shape of this and purpose of this qualified electronic attestation. So if we consider that this metadata, those metadata could comprise a recommendation from the trusted service provider, such as the reliant party is advised to perform or to ask for one eIDAS attestation substantial when getting this qualified electronic attestation, in order to make sure that this qualified attestation is bound properly to the holder, to the legitimate holder. Delivering an attestation is not a proof in itself sufficient to bind the holder, of course, and an additional authentication protocol is needed to allow the reliant party to lend credence to the direct relation between the bearer and the attestation. And then here comes the actual authentication that could be performed by the user. As example here, the user could involve one electronic identity card or so that would interface through NFC with his mobile or her mobile, and then the proof of authentication will be signed with a specific authentication key, and this will be returned to the reliant party, upon which the reliant party would grant access to the resources to this user. So here we have seen, when unfolding this flow, that the use of this kind of request for either, for here specifically for a particular type of attestation, may be very useful in the eIDAS context. And this relies on the namespace convention that were adopted by this ISO standards in order to facilitate any operation of data element investigation or questioning, or as well authentication overall. Thank you. This was the principle I wanted to share with you with respect to the mdoc usage. The floor is yours, John Daniel.
Thank you, Murad, for this presentation, and Sridharan. Do we have any question? I think we can open the microphone if you want to ask any question to Murad and Sridharan. And eventually you can also use the chat for posting the question. I have one question myself on what you presented today and this proposal. Is it something you feel that will be in the toolbox? How do you think this will be, this proposal will have traction in the wallet?
For sure, the two standards on the ground of which I made this presentation are likely to be referenced in the toolbox. I was talking about the series of standard and 1813 part 5. There are several hints that tend to inform those two series of standards will be part of the toolbox, definitely. And the benefit would be, in my opinion, at least for the authentication protocol, that is one particular aspect that I mentioned here. The benefit would be to use this kernel of functionality that comprises this data element naming convention, and as you have seen, it facilitates significantly the authentication protocol with the mobile, while making an abstraction of the actual process that would happen under under the curtains, I would say. Java card could come into play here by achieving the interaction between the mdoc and an applet. Of course, this mdoc could be just an abstraction or acting as a proxy, and as it supports this naming convention, it allows as well for an extensibility that is quite useful. Extensibility meant here in that any implementers, any issuing authority could decide of a series of data elements with their naming convention that would allow for, let's say, specific authentication protocols or specific data element, etc.
Okay, and you mentioned Java card as a mean for that. Do you know if there are any other contenders? And I think interoperability is important, and standardization. Do you feel the need to have some kind of interoperability or standardization of this, what I would say, Java card applets?
That's actually, yeah, very interesting question actually, because this abstraction layer that was designed on purpose in order to separate the secure area from the application layer that we have seen is something that delivers to or offers to Java card the entire possibility to achieve any kind of authentication protocol relying on any kind of secure area, etc. So there is no specific need, you see, to support a new API or so, but existing APIs, or as long as it allowed to achieve authentication, you see, on board the device, could be engaged in this process. So as long as an API, so Java card API, allows to achieve authentication protocol on board the device, as example by checking a reference that would be internally hosted on this secure area, and to verify it against the sample delivered by the user for biometric verification or so, Java card will come into play. So it is possible, of course, to expand Java cards for this purpose, but whatever existing mechanism with Java card to achieve authentication on board the device could serve for the mdoc.
Okay, thank you. Do we have any question from the attendants?
Yeah, this is Manfred Roth from Infineon. Murad, hello.
Hello.
I have one question to your very last slide, slide 23.
Yeah, just let me touch back. Here it is. Yeah.
Yeah, thank you. So the perform authentication via this smart card document, which is called driver license, you request a holder binding, or you suggest to request a holder binding eIDAS attest sub. Isn't that something which can be done in this level, also done by the mobile device?
Oh,
because because the security level is not that high. So this is something I would expect that this can be done also by a mobile device. So if it would be a test level high, I expect that it can be done by such a smart device only.
You're perfectly right. You're perfectly right. Sorry.
My question is, what do you think about derived credentials? So I think this user device, this mobile device, is completely working without derived credentials. Is my assumption right?
Oh, yes. With respect to the first question, if you don't mind, related to eIDAS attestation sub, that could be just attestation low. So using a card could, an external card like driving license, as example, could intervene if the eIDAS attest is high. Probably it's more likely. You are fully right with this respect. We can make abstraction of this external hardware token here in this context and rely only on the operations executed on board the device to achieve this eIDAS attest sub. Now, with respect to the derivation, yeah, whether this concept considers that the attributes are necessarily on board the device beforehand, I wouldn't say so. It's possible. This is another aspect related to the way the attributes are provisioned. They could come as well from an external token. They could be derived at the moment of the transaction. At this point in time, with regards to the regulation text, there is no restriction, and this would depend on the issuer, of course. There is no restriction, in my opinion, to derive attributes out of an existing identification token that was already notified. And this derivation could deliver all or part of the available attribute to the mobile just for the purpose of a running transaction where those attributes could be conveyed to the reliant party with user consent. So this is a possibility. What you are evoking here is definitely one possible way of achieving the attribute delivery, where the mobile could serve only as a proxy, if I may say, intermediary between the notified token, hardware token, and the reliant party, for sure.
Okay, thank you very much.
Thank you for your question.
Any other question from the attendants? Okay, so looks everything was really clear. Sridharan, Murad, thank you for our presentation. That was very interesting and putting into perspective what Java Card can bring to the digital identity project. You will receive a link to the presentation. If some of your colleagues missed the presentation this morning, there will be another session in the afternoon. You can watch the replay and the replay of last week's webinar on Java Card website, and stay tuned. We have a set of other very interesting presentations coming during November and early December. So stay tuned and spread the word. Thank you, everyone.
Thank you. Thank you, Jean-Daniel. Thank you all.
Thank you.